Welcome to an example from a possible test question that I want to explain to you, because this has a trick in it that gets a lot of people, so I want to make you aware of it so that you can get this kind of thing right on exam 3. A manufacturer claims that fewer than 6% of its products are defective. In a random sample of 97 such products, 5% are defective. Find the p-value rounded to 2 places for a test to support the manufacturer's claim. Okay, how do we do that? Well, first off, we always have to, following the notes, the exam 3 notes, they say do the claim first. What's the claim? Claims that fewer, that's less than 6%, this is a p, we're talking about percentage, fewer than 0.06, you got to change that to a percentage, right? Move the decimal back 2 places and change it to a decimal, 0.06. That's what's being claimed. And then we write the HO and the H1. Remember, the HO is always equals. And then the H1, well, one of these two, either HO or H1, has to be exactly the same as the claim. It can't be HO because HO is always equals. So in this case, it's going to have to be H1, and we write claim next to H1. That's how we always begin these. So we first off identify the claim, fewer, less than 6%, decimal 0.06, and then you always write weak evidence next to HO, and strong evidence next to H1, because it takes weak evidence to conclude HO. It requires strong evidence to conclude H1. Okay, so now let's dive into the test. It says what it wants us to do is do a p-value for a test, hypothesis test. Well, if you look at the exam notes, exam 3 notes, here maybe I could grab those for you, and you can see them. I can do it somewhat rapidly here. There we go. Exam 3 notes. There it is. So back to here. There we go. Okay. So exam 3 notes, it says basically, how do you know what to do? Well, if you look at it, is it a p percentage? Yeah, it is. It's not a mean. So what do we do? 1 prop z test. So 1 prop z test. So we go on our calculator and we hit stat. The stat button, which I just did not hit. Stat, go over to test, go down to 1 prop z test, which is number 5. 1 prop z test, and hit enter. So, and then when you do, it'll ask you for a few things. It'll say, what's P0? What's X? What's N? And what's the proportion? Okay, so this is where the trick comes in. So for the first part is not a trick, just 0.06, no big deal. The P0 is always the number next to H0. That's what the little 0 reminds you of. Now, what is X? Here's the trick. This is where it gets a little tricky. If you look at the notes, this is the exam 3 notes. X is the number asked for. It'd probably be helpful to add to that must always be a whole number. No decimals. Both of these. They must be whole numbers because it's a proportion. It's X over N. It's like, 10 people out of 30 people or something. It's whole people. It has to be a whole number. So no decimals there. So what does that mean? Well, that means, how are we going to do it first off? What number even goes there? It says in a random sample of 97. Well, that's our N, right? That's clearly our total sample size. That's always what N is in every statistics problem. So out of 97, 5% are defective. So this is the number being asked for. And it's got to be a whole number. Oops. I'll write that in a minute. Number being asked for. What do you mean being asked for? Well, what are they asking for? What are they claiming? They're claiming that fewer than 6% are defective. So we're talking about the number that are defective, right? This 6% thing is the percentage anyway that are defective. And same thing here, the 5% defective. So the number being asked for in this problem is the number that are defective. That's what we're testing. How many are defective? Well, it said 5%, right here it says 5% of, 5% are defective of the what? Of the 97, right? It means of the random sample of 97, 5% of them were defective. Well, how many is that? We can figure that out, right? Here's the trick part that you might not be aware of. Of means multiply. So you need to know that in all of math, of is multiply. So 5% of 97 is 5% times 97. If you multiply that on your calculator, let me do that. 0.05 times 97. I'm getting 4.85. So we round it to a whole number, 5. Because, let me add that note here. It must be a whole number. Why must it be a whole number? So we put it in as 5. Because it's how many actual people, or in this case products. I'm sorry, not people, but products, right? So look at what they're saying there. They're saying that they took a random sample of 97 products and 5% were defective. Well, how many were actually defective? Well, 5. That means 5 out of 97 were defective, which is 5%. So we got to put the number being asked for right there, 5 out of 97, which is the 5%. How did I come up with that? They told me 5%, so I took 5% of 97, 5% times 97. Came out 4.85, but you can't have 4.85 how many products were bad, were defective? 4.85. Well, what does that mean? How is 0.85 of a product bad? No, it means 5 products. You might think, well, why'd they say 5%? Well, that's just the closest percent, right? If you take 5 divided by 97 in your calculator, you would get 0.0515. So it's about 5%. They're just giving a rough estimate. 5 out of 97 were defective, you see. And that's about 5%. So, but you've got to put the actual 5 here. That's the trick I wanted to show you. It must be a whole number because it's an actual number of products that were defective out of 97, you see. So 5 out of 97 were defective. That's what we're putting there. 5 out of 97 were defective. And then the proportion, that just always matches H1. What's H1? Less than. So that's less than. Put in the less than there. I'll do it on my calculator right now. On Prop Z test. 0.06. 5 out of 97. If you don't put in a whole number, it'll give you an error. If right here you put in like 4.85, the calculator will tell you error because it knows it needs to be a whole number. All right, when I do all that, I get a p-value equal to what? 0.36. 0.36. There it is. There's the answer to that question. So the whole trick then, make sure you know that this has to be a whole number, and you might need to take the percentage and multiply to get it.